So sometimes I go for a pretty long bike ride, and when I do that, I usually end up kind of getting an ache in my lower back or in my neck, kind of from being humped over the handlebars for a really extended period of time. And when I do that, if it's really bothering me, sometimes I take some medication for it. So some medication, and the medication that I prefer to take would be an NSAID. So an NSAID, and you might have heard of some common NSAIDs. You might even take them too. Aspirin, for example, is an NSAID, aspirin, and ibuprofen is another example. Sometimes that's called Motrin, but it's the same thing, ibuprofen. But these drugs, they help reduce that ache, because that ache is caused by inflammation in the muscles of my lower back and in my neck, and these are anti-inflammatory drugs. In fact, NSAID stands for non-steroidal anti-inflammatory drug, and part of the reason why these medications stop that ache is because they stop the production of prostaglandins. So prostaglandins. You see, prostaglandins are lipid molecules that help signal inflammation. So if I can stop these prostaglandins, then I can stop the kind of further and to some extent the past production of this inflammation and its effect on my body, which would be the ache. And prostaglandins fit into a larger class of lipids called non-hydrolyzable lipids. So remember that we broke lipids down into hydrolyzable and not hydrolyzable. Hydrolyzable are the lipids that can be further broken down into smaller units through hydrolysis reactions, and then we have the ones that can't be. So prostaglandins fit into this kind of category of not hydrolyzable lipids, and we talked about how the hydrolyzable functions might include energy storage and kind of this structural function. Well, the not hydrolyzable lipids, their main function revolves, at least in our body, around signaling. So signals, just like the prostaglandins signaled this inflammation up here. So I think I have a picture of prostaglandins that I can kind of fade in for us. And this would be the prostaglandin, PGI2 here. But prostaglandins are probably the most notable of a group of biologically active compounds called eicosanoids. So let me kind of write that in here, eicosanoids. And eicosy is actually Greek for 20. So these are compounds that have 20 carbons, and you can count, if you want, the carbons in PGI2. But eicosanoids are kind of famous for being local mediators, which means they signal an effect kind of in their immediate environment. And prostaglandins are probably the most noteworthy of these eicosanoids. So an example of the effects that prostaglandins stimulate would be inflammation. We covered that. They also lower your blood pressure, prostaglandins. They lower your gastric secretions. They inhibit platelet aggregation. But there are a lot of signals or effects, at least, that are signaled by these prostaglandins. So they're a signaling lipid. Now, another signaling lipid that are kind of pretty famous, let me pull in a picture of them, are steroids. So I'll write that in as well, steroids. So steroids are a tetracycline lipid, which means they have kind of 4 rings, 4 cyclic rings, and you can see this in the picture here. Maybe I'll get a darker color. So we'd have 1, 2, 3, and then 4 rings, and in each of these steroids, the 4 rings, 3 of them are 6-membered rings, and the 4th is this kind of 5-membered ring here. They all have this 4-ring structure, and then they differ in their little substituents. And I've already done kind of an in-depth series of videos on the structure and functions of steroids, but I'll keep it brief here and just kind of mention that steroids are another non-hydrolyzable lipid that have a signaling effect on our body. So cholesterol would be a steroid. This one right here is actually testosterone, and this one is progesterone. progesterone, and these are examples of sex hormones in our body. They signal things like puberty, for example, and then you have some other steroids like the corticosteroids, cortisone and aldosterone. But if you want to hear, I guess, a lot about steroids, you should definitely check out that other playlist of videos. But the last non-hydrolyzable kind of signaling lipid that I want to talk about are actually vitamins. So fat-soluble vitamins. And I suppose I misspoke a few minutes ago when I said that non-hydrolyzable lipids all have this signaling function, because fat-soluble vitamins really function more as cofactors. So cofactors, which means that they help some enzyme in our body perform a function. Our cells don't make these compounds, so we have to ingest them to help these enzymes perform their function. And there are 4 fat-soluble vitamins. We have A, D, E, and K. And I think I've got a picture here that I can pull in for us. This one right here is A. And vitamin A is also called retinol, and it's needed for light sensitivity in our vision, as well as kind of healthy mucous membranes. It has a couple different functions in our body. We have vitamin A. We also have vitamin D. Vitamin D helps regulate phosphorus and calcium metabolism. So deficiencies can cause a number of different bone diseases like rickets and osteoporosis. And so we got A, D. We've got E right here. Vitamin E is an antioxidant that helps protect our neurological function. And then vitamin K at the bottom. Got A, D, E, and vitamin K regulates the synthesis of prothrombin, which helps our blood clot. So a lack can cause some pretty serious bleeding issues. And I don't know why it kind of sticks in my mind, but A, D, E, and K are the fat-soluble vitamins, and they fit into that broader category again of non-hydrolyzable lipids, which primarily function as signaling molecules, and I guess for the vitamins as cofactors as well, all within kind of that big category of lipids.